Learning Consortium, the Lab Sweden, and the Cyber Security Lab. Welcome everyone online, and also very welcome everybody here in the audience. Great to have you here. We are very happy here at AI Sweden today to be able to do this joint launch event. Very exciting future, and we're really hoping that this will create a lot of opportunities. My name is Ebba Josefsson Lindqvist. I'm project manager for the Data Factory here at AI Sweden. And the Data Factory holds the test bed that also holds the very exciting Edge Learning Lab, which is part of the focus of today. And what we're hoping now with this launch is that we together will create breakthrough innovation and research, and that we will also grab this unique opportunity and shape the future together. So with that, here you can see the agenda of today. We have a really nice list of international speakers and also AI Sweden colleagues that will walk us through and give us some personal thoughts on what these opportunities from today and on can be. And with that, I'm not gonna take any more time, but I would love to welcome our first speaker, Gillblad, to come up on stage. And while you're coming up here, I want to say if there's any questions or any thoughts, please use the Q&A functionality or even the chat functions that we have here in Zoom. And for questions that we can't answer today, we'll make sure to respond to them later. And with that, Daniel, you are one of the co-directors of AI Sweden.
Absolutely.
And what's your main focus as the co-director?
At AI Sweden, I'm mainly focused on the technical and the research strategy side of things, and making sure that we're doing the right things at the right time to have the maximum impact as possible, basically.
Sounds easy.
Super easy.
Somewhat of a challenge. And then we also have this concept, edge learning.
Yes.
And now you will let us know a little bit what that is.
Exactly. And what we mean by the expression and why we think it's so important to start working on immediately.
Thank you so much. So the floor is yours.
Thank you very much. Right. So again, I'm Daniel Gillblad. I have a background within AI, machine learning, large-scale data analytics, and so on. I'm going to talk a little bit about what is edge learning. When we say here edge learning, what are we sort of talking about? What kind of areas, what kind of challenges, what kind of solutions do we want to focus on? And of course, this is a super, super broad subject, but let's get into basically the what's and whys and so on of edge learning and how we define it here. So for quite some time now, we've sort of been on the edge of computing. It's not necessarily just huge, large-scale data centers, cloud services, and so on anymore, especially when we're thinking about broader applications. We are quickly moving computation towards what we call many times the edge, closer to experiences, closer to data collection, and not necessarily just in one or a few logically centralized compute solutions, basically. So this is a development that's been going for quite some time. At the same time, we've also had fantastic developments in mobile devices and so on that have now capacities that, when I began doing research within machine learning, the computers we had, the really, really big clusters and servers, they had nothing on the phone that I'm carrying in my pocket now. We can do stuff, I can do stuff on my phone millions of times faster than with the computers that we actually had running those kinds of algorithms. So we have a different opportunity now, basically. So what we can actually do now is start looking at how do we scale real, true, societal-wide intelligence out into real-world, large-scale applications. Now we have the compute, we have the communication to actually start making this possible. So at the same time, we've also realized, even though I've been a proponent of it for a very long time, machine learning works. We have seen proof of the proof of the proof now these last few years that it's actually better to create an algorithm that can take in data, learn from the world, rather than manually inject knowledge and things like that. We have really proven this to be true on way more complicated domains than what we used to work in, within language, within image, video, modalities that were sort of out of reach just 10 or 15 years ago sometimes. So we know that this is a super important area and we want to make use of it. But now we're talking about data. We're talking about access to data. And this sort of creates a little bit of a dilemma for us. So if we really want to pursue these methods in large-scale applications, sometimes even smaller scale applications, we need to make sure that we can learn from all the data that is relevant, basically, to make these models as good as possible. And data tends to be a little bit stuck. So we were talking about it like 10 years ago, that data is the new oil, it's super valuable and so on. Perhaps we can start sharing it. Perhaps we can in some instances, but perhaps data and information wants to be free. It feels like it's pretty stuck. And just the fact that data is valuable makes it sometimes a little bit difficult to share. You might actually expose yourself as a company by sharing data. You might expose personal information that you do not want to expose to other people by sharing raw data. And some of these things are not going away. So how do we solve this dilemma? We want all data to put it into our algorithms and learn from it. So we need data sharing. Well, typically the question when we put it like that is, ask a different question. And the question in this case is basically, so what if we don't do data sharing? We as humans have lots of experiences and input and so on. We learn ourselves. Our collective experience is much bigger than that, but we don't share sensory experience or raw data points. We share knowledge. We share abstracted knowledge between each other. So let's do the same for these kinds of intelligent systems, basically. Let's look at how you share knowledge and models rather than raw data, and what happens when you do that. And this is the essence of edge learning for us, staying close to the data and sharing these kinds of models. So let's look a little bit at let's call it a canonical example of what edge learning could be. So perhaps all of us have heard of, worked with, and perhaps even sometimes deployed federated learning in the last few years. So if we look at federated learning, the whole idea is basically that instead of taking every single data point, sending it down to a central place, using a neural network or something like that to learn to predict or classify something, then we basically train lots of different models for a while. Then we send them to perhaps a central place, combine these models by, for example, averaging the parameters or by a different but similar process. Then we redistribute everything and we continue to learn. And this actually works quite well in many scenarios. It might be difficult to keep everything in sync and actually make sure that all of these models continue to learn something useful, but we have at least proven that it works in many practical scenarios. And perhaps you don't even need a central point. You can have different computational architectures, such as no central combiner or something like that, but you actually learn a lot. You talk to, for example, neighbors in a network or something like that, exchange models, and then redistribute and continue to learn. And these are the type of solutions that we really believe will unleash machine learning and AI in lots and lots of new different applications. So let's have a look at them. And of course, these types of solutions are not the end of the line. We can imagine lots and lots of different other approaches by just creating models of the world, sending them around, using them as ensembles of learners that we can perhaps use in many, many places and so on. We can use generative models that can generate new data that represents someone else's experiences, etc., etc., etc. But these types of approaches will be with us for deploying AI and machine learning on a really, really big scale. So if we look at some of the challenges involved with these kinds of approaches, then what should we really focus on at the moment? Well, of course, we must make sure that these actually work in the real world. And to work in the real world, you have to sort of assume that not necessarily everyone is friendly, who will send you the right data or the right model and so on. So we need to make sure that we can handle these kinds of situations. So of course we have to look into that. Of course, these types of models, if they represent, say, for example, very, very distilled information, learned from data and so on, we want to make sure that, of course, we shouldn't expose any personal or sensitive information. Well, perhaps you can actually query the model to find out some sensitive information anyway. So how do we make sure that that doesn't happen? Or can we at least provide some kind of guarantee of how far you can go, how much information you can protect, and so on. So how do these models actually scale in practice? How can we actually make sure that these systems do not break down, that they continue to learn with thousands or millions of individuals in some cases that need to communicate with each other and update each other's knowledge? And all of these experiences might not be relevant for everyone. So for example, a traffic model for part of Sweden is not necessarily relevant for parts of India and so on, but they might be parts that are similar. So what knowledge should we share? What shouldn't we? All of these kinds of systems and solutions and so on will be explored here within the Edge Learning Consortium. And we will make sure that we will test these in a practical, engineering-focused way, basically. If we take a few examples, so take the car industry, for example. Of course, it's a lot of compute power in the cars nowadays. They can perform a lot of learning by themselves. But it might not be possible to actually send up all raw data. So of course, this is a necessary solution. But it's also a good example of legal challenges. You might have to learn from cars both in China and in Europe and the United States, but you're not going to be able to exchange information between these, at least not raw data. So here, again, we have a solution. So if we look at, for example, healthcare, here you have a good example of ethical challenges, personal integrity and personal privacy challenges and so on, that we need to make sure that we can address. So it sort of spans up a different kind of problem set. If you look at, for example, space, and we have the European Space Agency here today, I can imagine lots of different things, but especially if you want to actually push some of these methods out into orbit, so to say, you're going to deal with quite a lot different basic restrictions on communication and energy and all of these things that make it super exciting. So how can we actually make these things work? So all of these different types of applications actually span up different parts of the problem area that are really, really important to solve. And we can use these together to create practical foundations of edge learning. That's our goal, basically. And if we then look a little bit into the future, because the future is going to be here way sooner than we sort of expect, I think an interesting parallel development is actually that in many cases in machine learning, we're quite rapidly moving away from the one single machine learning model solves a specific complete problem, but rather we're combining relatively large, sometimes more foundational models for language, for computer vision, and so on that might be pre-trained and then specialized into bigger solutions. And this also plays directly into the Edge Learning Consortium and the Edge Learning Lab. So how do we combine these types of models, sometimes working on different types of data, and with slightly different semantics and so on. So how do we create solutions that can work with these kinds of things? In the future, if we're working with these kinds of models, then we're not just exchanging simple parameters necessarily and so on. So I'm also very, very interested in seeing what will the actual language between these devices and systems and autonomous systems actually look like? How are they actually going to talk to each other? What language are they going to use? And this is also a super interesting problem that we're definitely going to see in the future. And with edge learning, we're also further pushing the boundaries of, now when we're teaching machine learning and analytics and so on, it's super easy to say that, okay, look, listen, here you have a data set or a set of images, and you're going to solve this problem, you're going to train it, you're going to evaluate it, and then you're done, and then you're going to deploy it. That's not necessarily how things work in the real world. Definitely not in a decentralized scenario where you have lots of different actors and so on, where data in one place might mean slightly different thing from another place. You have devices coming in and out into the system, etc., etc. So how do we deal with these things? Well, a lot of it is actual engineering. You have to work with engineering practices, not only doing research into specific fields and algorithmic solutions. And here we have a unique opportunity to combine the use cases, the engineering, and the scientific research into methods that actually solve all of these problems. So essentially what we're doing is we're creating, engineering the future fabric of machine intelligence. And I'm super excited about this because it's something that I truly strongly believe in. Intelligence is not necessarily just one single algorithm, one single entity, but it's an emergent property. It's what some authors used to call society of mind, basically. It's lots of simpler solutions working together to provide something that really, really is truly intelligent. And that's what we're building here, basically. So to summarize a little bit about why we're doing it here at AI Sweden, well, we've touched all of those points already. First of all, this is a huge challenge, right? No one can do this on their own. So we need to build critical mass somewhere. And AI Sweden is a good place to start, basically. We have partners with different expertise that can actually share their experiences and complement each other. And we have the different types of use cases that span up different parts of the problem to make sure that we can create good engineering, methodological, and best practices that work at a larger scale, basically. This is, I believe, one of the futures for research and innovation, this kind of consortium coming together. And for everyone involved, this is also much larger than just looking at a single business case, a single application. It's how you will build your business in the future, but also how we're going to tackle a lot of the societal issues that we're facing right now. How do you trace or learn to diagnose in a pandemic, for example, where you cannot exchange data? How do you build large-scale, efficient energy distribution systems where you cannot share all data, etc., etc. So with that, I'm going to say thank you and hope that I've provided a decent backdrop for the rest of the speakers that will come up with more challenges, more ideas, etc., for what you can do within the Edge Learning Consortium.
Thank you very much, Daniel. That was very inspiring. And now we know a little bit more about the setting, the edge learning. And for me, having a background in law, I think this sounds quite promising.
Yeah,
actually.
I think so.
Some data privacy perspectives, etc.
Etc. And it's not easy to solve, right? We don't really know what the legal implications actually are. We don't know the business cases for these kinds of systems. How do we actually build business cases for sharing models of data and so on? But it's super interesting to explore.
And maybe it's also up to the lawyers to find out a bit about how we can use this.
Absolutely.
And work with the technicians, of course.
Absolutely.
So some cross-sector industry and overlapping in between
Yes.
these expertise is really something we look forward to.
Yeah.
Thank you so much.
Thank you very much.
Great. And now we will head on to our next speaker, visiting us here in Gothenburg, Sweden, from South Dakota in the US. So please come and join me on stage, Dr. Josie Marie Griffiths, President of the Dakota State University in Madison, from South Dakota. And you will share some of your personal thoughts on the opportunities here.
Yes, I will.
Please, the stage is yours.
Okay. Thank you, Eva. Thank you very much. I'm glad to see you all here. I was told that this talk should be a little personal, so it's going to be a lot personal. And for those of you that are in South Dakota and watching this, you're going to find out things about me that you do not know. So just take note. And I did change the title of my talk. Sorry, Matt. I decided to call it Finally to the Edge and Beyond. You know, I feel that there are a lot of advantages of longevity in that I've experienced both the promises and the disappointments of various technologies over my career. I've seen dramatic evolution in computing, and Daniel was exactly right. My doctoral work was computer simulation. And as I was doing that work, I could only use our mainframe computer once a week. So I ended up using 4 different computers, 2 in London and a computer center at Oxford and Cambridge. And every week I'd travel around and give them my simulation and they'd run it once a day. I've seen tremendous improvements in what we used to call storage, that's now called memory. It used to be a big issue for us, how to manage memory, putting data in, having to take it out, parking it somewhere, bringing it back. That's really not an issue anymore. Tremendous evolution in telecommunications and networks, from the ARPANET, the sort of pilot packet switching network that allowed researchers to communicate, through to the current day internet. And then seen tremendous improvements in artificial intelligence and machine learning, which started off in my experience, people at the University of Cambridge working on natural language understanding, partly because of the European Union requiring translation from one language into multiple other languages. So a lot of work going on there. So I thought I'd talk a little bit about my experiences and then I'll tie it back to the present day. So my first job after I graduated was with the UK National Health Service. I was responsible, I was a special reports officer, and my responsibility was to analyze computerized patient data. We did have an electronic health record in those days, a long time ago, data from all the hospitals in Southeast England, including London. And what I had to do was to look at hospital performance and doctor performance in terms of how well did they allocate resources, were the beds used efficiently, how many people were diagnosed and treated for what kinds of diseases, and how many people died as the outcome. So doctors were a bit nervous when the reports came to me and I had to analyze them. Quite interesting. But we could only do so much because we had a mainframe computer. It was slow. Anything fairly complex in terms of analysis was bumped to an overnight or weekend run, so it wouldn't disturb the other business that they were running on the mainframe. Then a little while later, I went to work with Cancer UK. I continued to work on databases, retrieving and analyzing data, and then at the Department of Energy, the US Department of Energy and the Oak Ridge National Lab, I moved from single databases to distributed databases, where we had to learn to run things in parallel. So we used to talk about parallelizing our code. That was a skill that we taught students. And then moved to heterogeneous databases, which is a term that's coming back now as we talk about edge computing. Electronic health record, data, text, images, chemical and biological structures, genomic, proteomic structures, etc. All of those were the different kinds of data that we were trying to pull together to create an understanding of the human, the individual human, and then populations of humans. And then just to make it a little bit harder, we added into that environment multiple levels of security. So multi-level security is another term that I'm hearing again in the context of edge learning. From there, I moved on to AI applications, developing algorithmic models for diagnostic and treatment protocols. So, you have a headache today, how bad was it? How often do you have it? Is it an ache or a sharp pain? depending on your other symptoms, we're going to diagnose you with migraines or migraines, whatever you call them here. And as a result of that, here's the treatment then that we would recommend. So we did these protocols in a number of different areas. And then I said, but now we have the internet. So part of my role was to get these online and to get these models working in almost a real-time update kind of mode, providing feedback from actual patients as they occurred, and then modifying the models, just as Danielle was talking about, modifying the models. And the problem was we didn't really have any good networks in those days. There was a lot of concern about privacy. We didn't have our HIPAA regulations at that time for health information. So we only got so far. And then I went to the University of Pittsburgh, and I moved on to working with what we called intelligent agents. You could say an AI algorithm if you like. They were neural net based, and we sent these intelligent agents roaming around the internet to go and pull information and come back and report in a federated way. And then also swarms of agents working sort of almost autonomously, feeding the data to each other, but not necessarily to a central control, and looking at what could be done. That was scary for some. The notion of autonomy is very scary for a lot of people. So what was the problem there? Well, we had the compute power because I was at the Supercomputer Center, but the AI capabilities were limited. And at that point, we had another, what we called an AI winter for funding for artificial intelligence. So in the United States, we've had periods of funding AI, and then the AI winters and the funding goes away. And then, 10 or 15 years later, we had another surge of AI funding. And we're right now in another surge, but we had an AI winter at that point. Then I was on the President's Information Technology Advisory Council, and we recommended national developments in the electronic health record. So we ended up, actually, there are only 2 formats for the electronic health record now in the United States, and we have crosswalks that can fetch data between them. They can go back and forth. We created the Office of the National Coordinator for Health Information, and then there was the development of privacy practices, the HIPAA regulations, and then what we called health information exchanges. So we are able to exchange health information in the United States through specifically designed exchanges that exist across the country there. Then at Chapel Hill, I worked on the intelligent hospital room. How can we bring more technology and intelligence to the hospital room so that when the doctor comes, the analyses have been done, and then he can make a decision based on analyses that have been performed while he's not actually in the room. And those activities we also did some work on what's called clinical and translational research. That was, how can we take the work that's done in research and get it out into practice sooner? So we started looking at workflows and who should be informed of what development at what stage, et cetera. So all of those activities pointed us towards the concept of what we call the patient-centered medical home and virtual healthcare beyond telemedicine, actually. Problems, physician resistance, and we still have that. The internet digital divide, some had access to the internet, other people didn't. So if you're trying to do virtual healthcare, it's very hard when people aren't connected. And then what we call the last mile issues, which still exist to this day. So all of that experience doesn't actually mean I have any of the answers. It just means I'm old. But it does mean that the collective AI machine learning community has access to potential solutions that could in fact now be tested in our new, more technologically advanced environment. So I'm very optimistic, and I'm actually excited at the work that I'm hoping will be starting here. And you might ask me why. You've had all these issues, right? And the technology only took you so far and then you couldn't go any further. But I see a resurgence in investment and developments in AI and machine learning, both federated and swarm. Edge computing, we see a lot of heterogeneous devices at unprecedented levels of scale when you think about the numbers of devices that exist. GPUs and advanced AI chips, hopefully they will flow soon again. And they give improved privacy, but there is going to have to be some redesign of security issues in that environment. I see a lot of promise in quantum technologies, particularly quantum encryption, which is going to completely change everything we've done in cybersecurity thus far. So a lot of work for some of us in cybersecurity. We're seeing 4G, 5G, 6G, and we're even talking about 10G networks. which with exploding bandwidth and ultra high speeds, which have reduced latency, that time delay that we used to see in the network, reduced it to much smaller than we as humans can detect. And so that's really good. And then most importantly, it's the combination of those technological developments into edge learning, the use of local capabilities to the extent possible with only deliberate and designed relevant processing at aggregate, subsequent levels of aggregation. Very, very exciting. So the issues I see for research in edge learning include algorithmic and model optimization in terms of functionality, performance efficiency, and those standard measures. I think interesting questions about what remains local and what is aggregated in whatever environment you're talking about. So for example, personalized or precision healthcare versus population healthcare, two very, very different environments, both of them important. By the way, probably at the moment, none of it's being done because all of those electronic health records have been used only on single transactions. Okay, we're working with one of the larger healthcare systems in the country, in South Dakota and surrounding states. They have never exploited their database beyond its use for the fact that a patient checks in, sees somebody, has a diagnosis, and then is discharged. So a lot of opportunity in that space. The importance of testing, evaluation, and verification and validation. Testing is one of those things that's always seen as an overhead function. Oh gosh, do we have to test this? How often do we have to test it? Yes, we have to test and test and test because it's very, very important to build trust in AI. People are already a little bit skeptical, especially if you're adding some level of autonomy in the system. Number 4 is cybersecurity. Absolutely essential. It's cybersecurity for AI. You need to secure the models and the data flows in both test environments and production environments. And by the way, AI will have applications for cybersecurity as well. So a sort of symbiotic relationship there. Then I think another issue that I'm not hearing a lot about, but I think is increasingly important, understanding and exploring human AI teaming for all participants. When does a human interact with the artificial intelligence and vice versa? And how do they each react to each other? How do they communicate with each other? I think it's going to be a very, very interesting area of research. So just briefly to comment on the opportunities we have here and the application areas that you selected. Healthcare, I think is a prime application for edge learning in both densely populated areas as well as scarcely populated areas. We have a major initiative in cyber health, and so we're very interested in working with you on that. In transportation, it's a sort of an obvious area, but we're looking especially at the food and agriculture sector because that's the sector that we have surrounding us in South Dakota. It's very, very important. Cybersecurity, I've mentioned, critically tied to AI. AI and cybersecurity are like this. And then in space, I think there are really what I call new opportunities well beyond the edge. Challenges, yes, but well, right now there's not a lot of regulation up there. And maybe that will give us some opportunity for a period of time until somebody starts regulating. So in closing, I feel as though I've been to the edge many, many times and I've had to retreat. Of course, the edge is constantly moving, but I had to retreat because of technological limitations alone. There were other limitations, social, economic, policy, etc., but just purely on technological limitations, I had to step back. But this time, parallel and integrated technological developments, driven in part by international competition and cooperation, I think will enable significant breakthroughs in edge learning and subsequent development of intelligences. So D.H. Lawrence once said, life is traveling to the edge of knowledge, then a leap taken. So let's work together to take the leap to a bold new future of multiple integrated human and artificial intelligences at and beyond the edge. Thank you.
Thank you very much for those inspiring words. And just before I let you go back to the audience, I wanted to ask, so you have one of the top labs on cybersecurity. And what would you like to see as the first challenges to be taken up or pursued within the Edge Learning Consortium?
Thank you. That's a good question. Obviously, one I'd like to answer. I think, first of all, we are very, since I've got a lab of cybersecurity experts, we would like, I think, to explore the use of AI to facilitate the the cybersecurity analyses that we're performing. I mean, they're very, very complex environments. We're working with companies, with governments at the state and local level, as well as at the national level. But I think AI and machine learning have a real application. And I dare say edge learning will have a major role in that. The other thing I think we can help with is all the AI that we develop together needs to be protected. And we get back to how can we secure the data at the various levels at which they're being stored and analyzed and passed from place to place. So I think those are two things that we could definitely engage with.
That sounds wonderful. And again, as a lawyer, it sounds wonderful.
Yeah.
Secure the data. Thank you so
Okay.
much for coming all the way and for your great speech.
Thanks very much. Eva.
Thanks.
Thank you.
And with that, we are changing perspectives a little bit and going up to orbit. We have also space applications within the Philab Sweden, which is part of the launch today. And with us, we do have Geraldine Naja, the Director of Commercialization, Industry and Procurement at the European Space Agency.
Thank you, Eba.
Hello, Geraldine. How are you doing?
Hello. I'm fine. I'm fine. Very happy to be with you. A little bit sad that it's only remotely.
Maybe next time we can see you here live. We hope
Certainly.
so. But you will share a bit of your perspective from space on these questions. So the floor is yours. Please go ahead.
Thank you, Eba. So yes, indeed, let's start with a little story. As you may know, today we have up to 3,000 cases per year of illegal oil dumping in European waters by commercial ships. And you can imagine it has a disastrous impact on the marine ecosystem due to solvents and metals such as lead and arsenic. So it's really a real issue for all of us. Now let's imagine you are a startup and you have developed a very efficient new software algorithm using satellite data to detect in quasi real time such illegal dumping. And by the way, already we have some well-established applications of radar data, but it's not yet fully operational service. So your software, your algorithm works really well for a very low cost, and thus your startup has good market potential. Now, what do you need? You need very specific and targeted type of data from satellites, but you will have to run your algorithm through enormous quantities of Earth observation data that you actually don't need. With edge learning, with edge computing, algorithms could be run on a device using locally generated data. And therefore, this would already discriminate an enormous amount of data that you don't need, and it would make it much easier for you to process a smaller set of data for your specific purpose. And thereby, your new business would actually be faster, it would be more cost efficient, you wouldn't need to send enormous quantities of satellite data to Earth, it would be easier to use, much more environmentally friendly, and last but not least, it would be less exposed to cyber threats. Now your little startup, you're very interested in edge learning, edge computing. You want a European company to help you in that respect, a European company which would have the experience to converge these technologies of edge learning with the processing of the satellite data that you use. However, currently, this technology is mainly developed in the US. We have seen a recent partnership between Palantir and Satellogic, and we have a first satellite into orbit on that subject, but it's not a European one. So you are a European company, you want a European solution. So why are we here today? We are here today to make sure that the new Philab and the new center that we are setting up and launching today can make Europe also the home to a whole new breed of companies that will provide such technology opportunity, in particular for our little startup. And this is really what I'm here to talk to you about. Because, for instance, the Philab that we are launching today is already connected to a strong network of ESA business incubation centers, technology brokers, and they could establish the link between the tech champion cases and the space sector needs. In the new lab that we are launching today, these use cases will need to have also a commercial eye, because they will need to survive and compete with regard to the US developments and elsewhere. And already we can identify that the market for edge learning is expected to reach 2 billion by 2026, and it will just be the beginning. We have started at ESA working on some use cases. We have in ESRIN, in our Italian Center for Earth Observation Data, we have already some work ongoing on on-orbit artificial intelligence and edge computing. In our Telecommunications Directorate, we have a project called EdgeSat, Edge Network Computing Capabilities for Satellite Remote Terminals. And we had a Kickstart thematic call, which just closed recently. So we have started working on this. But I believe that the center we are launching today will be quite an accelerator to what we are trying to achieve. But let's, for a minute, go back to the why. Why is edge computing so important for space? Well, we know that there are many sectors now that fully rely on space-based data. It goes from, of course, environmental monitoring to mobility, autonomous vehicles, precision farming, manufacturing. And space is actually the sector which is producing the largest quantities of data. You know that we already have in orbit a family of Sentinel satellites, which are providing enormous quantities of data to monitor our environment. It's the Copernicus system. And the commercial sector is also booming in space, driven by the applications of the use of satellite data, and private actors are fully entered into the sector, and they also launch their own satellites now. And actually, this creates two types of problems. First of all, more satellites in orbit means more risk of collisions, more space debris, that we already know. But also in terms of use, because the huge quantities of data that we generate in orbit for applications on Earth, for the time being, we use traditional AI models. And these transfer all the data generated in orbit to a single location where they can process it. Now, of course, transferring a large amount of data may enable better results and analysis, but in many cases, we don't need that, as per the example with our little startup. And this is not the best or most cost-efficient way. And actually, we are increasingly confronted to a congestion in the use of the bandwidth, because then we have already seen some disastrous impacts in terms of limitation of the amount of data that we can transfer, increasing the costs of the data transfer, and also we are confronted with bandwidth and latency limitations. And indeed, the solution to this growing problem is the distributed and federated way of working. It is edge learning, it is edge computing. And we are absolutely confident that this will be the solution to the congestion problems that we are facing. This device, actually, the edge learning and computing, would not need to be connected to the internet to analyze information, make decisions in real time. It would process the data, the satellite data, at the point of interaction closest to the user. It would save money and resources. You would not need to send all the large amounts of data to the Earth. It would be much easier to use, and etc., as I already explained, for our little startup. Now, going back to ESA and space, clearly we at ESA, we are not the experts on edge learning or edge computing, but we do see the huge possibilities created here, and we see the possibilities to have new opportunities, technology transfer, etc. And now we see that the AI race is, for the time being, I hope only for the time being, led by the US, but we are confident that the lead of Europe could be on edge computing and edge learning. And at ESA, talent, access to capital, fast innovation, this is our vision for space commercialization. This is what we are trying to put together and implement now at ESA. And we are currently preparing an optional ESA program that we will submit to our ministers in November, and to enable let's say, the journey from the first ideas to a full commercial marketable product. And in particular, we will focus on new emerging markets for private ventures. We do think that edge computing, edge learning in space could be one of these emerging new space markets. And we have a number of examples. I would just like to quote two examples. First of all, for exploration, for space exploration, the use of edge computing and edge learning would reduce the dependence on Earth and would reduce the time to get results for decisions in experiments like the zero gravity experiments or DNA sequencing. Also, the use of these technologies would improve possibly the crew health and facilities monitoring in preparation for deep space exploration. And it would facilitate new exploration by reducing the data need and increasing the data quality for rover activities. So for exploration, we have a use case. We have a second use case, obviously, for satellite and satellites data. We've already said that, let's say, bringing the data center services into Earth orbit and beyond would really lead to increased autonomy and resilience in decentralized networks. It would improve the capacities, it would certainly multiply the applications for satellite data, and it would also probably avoid collusion since you would have a software driver on board, such as edge learning on the Starlink constellation. So yes, I will conclude. To me, edge computing, edge learning in space is just the beginning. We are seeing it today. This is a very challenging time, and I'm convinced that your center will be at the edge, at the forefront also. And I seem not to be the only one convinced of that, because I would just like to recall that recently the large system integrator Thales Alenia Space has set up a partnership with Microsoft on the enabling of new capabilities in space, edge computing, etc. So yes, there is a bright future for edge computing and edge learning in space, and we are starting it today. Thank you.
Thank you very much, Geraldine. And from a PhilLab network perspective, what are the unique opportunities that you could see here for innovation when we have this platform where we merge healthcare, industry, hardware? What do you see for innovation? What would you first like to see happen here?
Actually, I think the great thing with the PhilLab and what we have seen with the PhilLab in Esrin is that we don't know what will happen. It is by definition unpredictable because we bring together different actors, different sectors, different disciplines, and we know that eventually innovation will happen, but we don't know where. We know that we all know that innovation usually happens at the interface or the boundary between disciplines. I also believe that it usually happens when, let's say, established industries start working together with researchers, young engineers from completely different sectors. So I can't tell you yet. But what I know is what I've seen in our PhilLab in Esrin, which really has been hugely successful with a number of completely new applications or new concepts for the use of Earth observation data. So I just wait and see.
Thank you so much. So basically we should keep our minds open and just wait for the breakthroughs to happen.
Absolutely.
Thank you so much for sharing this, and we're really now looking forward to being part of the PhilLab network with PhilLab Sweden. So really look forward to working with you going forward.
So do I, Eva.
Thank you, and goodbye.
Goodbye.
And we will now go a bit more to the hardware side of things. And we have Krishna Prasad Shastri with us, Chief Technologist at HPE for AI Strategy and Solutions.
Good afternoon, everyone. Hope you can hear me.
Yes, we can hear you. Very welcome. And
Okay,
now we will
great.
hear some of your thoughts and your perspectives on this. So please go ahead.
Great. First of all, thanks for having me and providing me an opportunity to talk to this group. I'm really looking forward for that. And yeah, as said today, probably I'm going to talk a little bit more about the edge learning, the current stage, what's happening out there, and what do we see it as kind of a future. Right? So the advancement in the edge computing and the edge learning is opening up many opportunities to advance the way people live and work. It can unite the hospital of the world to improve the healthcare, diagnose and cure the diseases. It can make fully autonomous vehicle a reality. For example, hospitals across the globe can come together, collaborate with each other to develop a machine learning model to diagnose a disease. The pharmaceutical companies can collaborate to develop best medicine, and the physicians can collaborate to recommend a best treatment plan. We know the early detection of the diseases will help in better treatments. But there are shortage of physicians and radiologists across the world. This makes it difficult for every patient to get the timely access to the physicians to diagnose and treat the diseases, which in a way impact the treatment options and the success rates. Artificial intelligence or machine learning can aid the physicians in diagnosing the diseases and treatment process. A properly trained machine learning model can diagnose the disease with the similar accuracy of a well-trained physician or a radiologist. For example, a machine learning model can diagnose the diseases by looking into chest X-ray images at the same accuracy or a better accuracy than a well-trained radiologist. So the data scientists and the domain experts are working together to develop and more machine learning models. They need a large amount of data to train these machine learning models. And this data need to represent a diverse set of patients at different stages of diseases so that they can develop a good machine learning model. We all know the machine learning model's accuracy depends upon the training data which is used to train the model. So that's why we hear the say, the models are as good as the data on which they are trained. Now, if you look at these data, which are generated at the edge location, for example, the hospitals, and moved into a central location or a cloud to train the machine learning model. That's mainly the training, as we said, needs large amount of data and also a complex compute systems to train a good model. These data aggregation creates several challenges. Primarily, if the hospitals are generating the data, say for an example, the medical images, they will have a restriction or a challenge in terms of sharing this data into a cloud or a data center, because these medical data contains patient private information. Say for an example, if the hospital tried to remove or mask the patient identifiable information from, say, a medical images, the images would still contain sufficient information to de-identify. For an example, well-trained facial detection or a facial recognition model can look into the MRI images and build the facial pictures or images which can be mapped to the photos of the individuals. So there are regulations like HIPAA, GDPR, which prevents the movement of data into a central location or a cloud. So this makes it challenging for the data scientists and the domain experts to gain access to the good set of data to train a model. Moreover, these hospitals realize that the data is significantly valuable in training the model. And they look for the ways to monetize the data which they own. And hence, they may not be willing to share the data freely with others in developing a model. Apart from this privacy and the ownership challenges, data movement also causes operational inefficiencies. So we know the recent or the latest medical images are large in size, and moving this data will not only impact the network bandwidth, but it would also consume a lot of additional storage. Also, the duplication of data creates an operational overhead in terms of data management and data protection. All these challenges are impacting the ability of the domain experts and the data scientists to build the models quickly. So here comes the edge learning, which helps to overcome these challenges. The edge learning enables the organizations to train the model at the edge. This eliminates the need to move the data into a central location, thus helps in preserving the privacy and retaining the ownership on the data. We know a large amount of data is required to train a model, and a given edge node may not have sufficient data to train a good model. So the edge nodes need to collaborate with other edge nodes to build a good model. The federated learning and swarm learning technologies enable this collaborative learning across multiple edge nodes. These frameworks enable multiple edge nodes to share and combine their learnings to build better models. Using this framework, an edge node will train the model or learn the insight from its local data and share that learnings with a coordinator. The coordinator gathers that learning from multiple edge nodes, in fact, all the participating edge nodes, and combines that insights to build a global model. In a technical term, if we are developing a neural network model, the edge nodes will train this neural network using the local data for a given time period. And they share the weights of this neural network with a coordinator. The coordinator averages the weight from all the participating edge nodes and sends the average weights back. The edge node continues the learning using this new weight. And this process continues till we train the model sufficiently to achieve the desired accuracy level. So with this technique, the hospital can now collaborate with another hospital to develop machine learning algorithms without sharing raw data. So thus they can meet the privacy and regulatory requirements. This approach enables the data scientists and domain experts to gain faster access to data so that they can develop and train the new algorithms much quicker. This collaboration also helps the hospitals which are having the lesser knowledge or the capability about a particular disease to work with another hospital which is having a greater insight about that particular disease and learn from its insight. and they can multiple hospitals come together and work. For an example, if hospitals across the globe form a consortium to develop a machine learning model to diagnose the rare diseases, let's say a COVID. Now, the hospital which is seeing more number of the COVID patients will share its learning and insight with the other hospital, which may be seeing a lesser number or no information about the COVID, but all these hospitals will learn together to build a good global model. The healthcare institutes, the research institutes, universities are all conducting multiple POCs and the pilots to test this framework. They have demonstrated the technology works with the POCs and its applications with multiple use cases like diagnosis of cancer, diagnosis of tuberculosis, etc. The federated learning provides the foundational capability for organization to collaborate with each other to develop better models. But operationalization of this model has another set of challenges. There are many factors which could impact the performance of the model at the production. Say the hospitals which generate the medical data and medical images, which might have SKUs. For example, the image generated by one manufacturer could be having a different resolution than the image generated by another manufacturing system. Or these images might drift over a period of time, or we might see a newer data drift. An example, again, with the COVID, we might see a newer variant of the COVID over a period of time. These skews and the drifts impacts the performance of the model. So we need a mechanism to detect the skews and drifts and its impact on the model performance. And then if it's impacting the performance of the model and make it to go down, we may need to retrain that model with the drifted data or a newer data to build a next version of the model. And in practice, this model will run in parallel with the current model to validate its accuracy. Once this new model is satisfactorily tested, this new model might replace the old model and it can become the current model. And the same process continues. And as you can see, this is a continuous loop or a continuous workflow. So the machine learning platform and tool vendors are developing various different technologies to monitor the model performance and diagnose or detect the drift, data drift or model drift. The service providers are trying to work to build an end-to-end workflow to make that end-to-end pipeline automated. So we at HPE in my team are also looking into this space and developing these technologies in terms of model observability to look at the performance, diagnose the drift, and also build a federated workflow. So we are seeing some very encouraging results at this moment, and I hope to see them mature in the next couple of years and to make it a completely automated solution. This would work well for a single organization. Now let's look at the example of multiple organizations which are collaborating together. An example of various different hospitals working together to build the machine learning models. Now, in such scenarios, these hospitals need a process to define who can participate and collaborate with each other. How can they share the data or the insight rather, it's not the raw data, but the insight from a data. And also these hospitals would realize, as I said, they would try to look at the monetization. So maybe a mechanism to look at how to incentivize the hospitals who bring more data or less data and things like that. So, and they need a very good governance mechanism to implement and manage these processes. In the world, and I have heard with my discussions with the practitioners in the healthcare industry, that in the world of medicine, the participants may not like a central authority to define and implement the governance of this process. Rather, they would look at every participant to be equal and have a decentralized governance mechanism. The blockchain technology can help in creating the decentralized governance. The blockchain smart contracts can help to digitize the legal contracts or the processes and make it execute in a decentralized manner. The blockchain has proven itself in executing the transactions across the organization in a transparent and trusted manner. In addition to this, the blockchain technology can also provide a foundation for developing an incentive mechanism. The crypto tokens, which are used in the blockchains, can act like a basis for developing a monetization mechanism in the collaborative network. So we at my team are using this blockchain technology to develop a decentralized, collaborative, edge learning framework called Swarm Learning. So which we have released with the community edition earlier. And then today we are announcing a release of this product for the general purpose usage. The edge learning, the end-to-end workflow definition and orchestration, and a decentralized governance and a monetization framework will enable organizations to collaborate with each other seamlessly. With a cross-functional, cross-organizational team coming together to build or advance these technologies and define the operational or the governance processes or the business processes would make it ready for a prime time or a mainstream usage. And I hope to see this technology mature into that stage maybe in the next 2 or 3 years. With the maturity of these technologies, we can expect, as I said, the hospitals of the world can unite to develop a better healthcare system or a better healthcare support to the citizens. The Edge Lab today, what we are inaugurating, it provides an environment and a various frameworks for the participant to develop end-to-end solutions. It enables the IT providers, the machine learning platform and the tool providers, the domain experts and the data scientists to work together to develop the new models or the new techniques and to sort out an end-to-end workflow and automate it, as well as define a business process to utilize these end-to-end automated workflows. I look forward to participating and contributing to this initiative. So I just use an example of a healthcare throughout my talk here, but you can think of its applicability into the other domains. For an example, the autonomous driving systems, wherein which these systems are trained based on the data acquired from the fleets, that is, the real images coming from moving vehicles. Now we can see the limitation in terms of the availability of a data with an entity, the challenges with the ownership, and the need for a collaboration. Similarly, you can look at that into your financial domain. Think of an example, the financial institutes developing a model to prevent the fraud. So an institute might find a mechanism to prevent the fraud depending upon a transaction which they see. But the fraudsters always try to look at loopholes in every different institutes and see how they can break into that. And now enabling these multiple institutes to collaborate with each other to share their insight without the raw financial data and to build a good fraud detection model can really help in preventing the frauds. So you can keep on looking at multiple use cases in various different domains. Thank you.
Thank you very much, Krishna Prasad. And before we head on to the next part, I just wanted to mention that also ESA, the European Space Agency, have mentioned that there's a big interest in looking at how blockchain technology could be used together with edge learning, for example. So I think we have quite a few interests in common that could cross over these different sectors. So thank you so much for that. And we really look forward to collaborating going forward.
Thanks again.
And with that, we'll come back to Earth and be a bit more hands-on. And we will have one of our colleagues at AI Sweden and also one of the person that we should thank for having a lab physically here located in Gothenburg, Sweden. And of course, we also want to highlight that the lab is always remotely accessible from basically all of Sweden and potentially also internationally. So with that, I would like to have Kim Henriksson show us the lab.
Thank you, Ebba, and welcome everybody to AI Sweden's Edge Learning Lab. And I must say it's an honor to follow in the footsteps of our prominent speakers that we just heard. Today, I will give you a brief introduction to the Edge Learning Lab and also tell you about some of the use cases that are ongoing here and how we see them connecting to PhiLab, the Cybersecurity Lab, and Edge Learning Consortium. A while back, we realized that, just as you probably have, there is a challenge about moving large volumes of data. There's also a challenge about how you can move it and when you can move it, especially from a GDPR perspective or across national borders, or even such simple between companies or healthcare institutions. How can we better facilitate collaboration between those? And how can we do it from a technical perspective, a legal perspective, and a business perspective all at the same time? And here we think that federated learning, decentralized learning, and I would say edge learning is one of the key ways of potentially doing it. The trick, though, is how do we actually do this? How can we get to a point where we know what to apply, when to apply it, how to verify our results, how to develop it over time, how to keep it secure, how to avoid being affected by adversarial attacks. How can we do it in space just as well as doing it in the healthcare industry or automotive industry? To help us answer these questions as quickly as possible, both from a research perspective, but also from an applied perspective, we at AI Sweden, together with our partners, have set up this lab. And I will now give you a brief tour of it. And hopefully with that, you will get a sense of how it can be useful for you in collaboration with our other partners. So over here, we have a scaled down representative version of what you will find in most organizations. So it's a multi-use platform. So it's a hypervisor environment, a Kubernetes environments, running various type of schedulers and whatnot. basically anything we can think of when it comes to what type of experiments are useful. This is also being adapted to whatever the actual need is at the time. So it's really a test bed in a lab in its true sense. This then can really represent, I would say, the central point if you're talking about federated learning or decentralized learning. The next part of that would be if we look over here. And that is edge nodes. And what we've set up here is a small selection of representative edge nodes. So we have a variety from like Raspberry Pis, Google Corals, NVIDIA Xaviers, NVIDIA Drive PXs, GPU machines, all the way from relatively small all the way up to NVIDIA A100s. We also have representative hardware of what's currently in the ISS space station. And soon we will also have representative hardware of what's in orbit in Earth observing satellites, connecting quite well to what we will do within PhilLab. On that topic, I want to tell you a story that connects quite well to how this lab came about, and also, let's say, the motivations for the Edge Learning Consortium in this setting, where the aspects of cybersecurity, space, manufacturing, automotive, healthcare, all sort of comes together as one. And that would be the case of a master's thesis that's actually ongoing right now. The idea was sparked in September last year during an event where we openly asked if you can train AI in space. Motivated by the question, if we can train something in space, we can reduce the amount of communication happening. It should potentially be easier to secure, and we can shorten the lead times as well, potentially. So Scale-Out Systems and Bedell teamed up with a couple of master students, and they actually set up a quite well-defined project where they tried to identify illegal fishing out in the ocean with actively on the edge trained model. And for quite a few of us, this doesn't sound as really exciting. But what they figured out is that they can do annotation on the edge by sending coordinates from legal fishing vessels and utilize that to continuously train models to identify fishing vessels, and using that model in turn to identify fishing vessels that are running without a transponder, potentially being illegal fishing. And that really ties together space, cybersecurity, and the whole need to be able to test something. That entire setup is actually test run right here behind me right now. And our goal is to facilitate more of this type of proof of concept projects in collaboration by partners, for partners, to help us reach a set of knowing how to apply federated learning as fast as possible. And with that said, I would like to hand it back over to Ebba.
Great, thanks so much, Kim, and it's really great to see parts of the lab shown like this, and everybody's of course welcome who want to see it live. So we would really encourage everyone who passes by to pop in and say hi and get a personal tour of the lab. And with that, we've had a lot of inspiration on what you can use Edge Learning for. But now we of course want to know how to engage and how to pursue these different challenges that we heard. So Mats Nordlund, if you would come and join me on stage. And yep, over the quarter. Yes. And you are the head of the data factory here at AI Sweden.
Yes, that's right. It's nice to be here and see you all. And thanks for introduction, Ebba.
Great, and you will tell us a little bit more on how we can engage and how we can work together in the Edge Learning Consortium, in the PhilLab, and also, of course, in the cybersecurity fields, and many others to come. So I think we have a few slides. Here we go. So first of all, shaping the future.
Shaping the future, yes, that's what we are about. And I think that rhymes with pretty much everything you've heard about here today. It's the ambition from what we heard Dr. Griffiths talking about, what we heard Geraldine Naja talk about, and what we've heard the hardware industry talk about through Krishna Prasad Shastri. It's a very exciting area, a lot of things happening now. And the thing that we're looking at is how do we bring it all together? And the way we found it here is to create a public-private partnership where we get together from different industries and from the public sector and work on this as a joint team. And we try to, in a way, replicate what you've heard about here, learning on the edge. You can learn, and we can define ourselves as the health edge, cybersecurity edge, mobility edge, and so forth. And then you learn on these different edges and you bring it together and federate it here, and then you propagate it out again. So in a way, you can say we're a recursive model of what we are trying to explore ourselves. So the idea is, how far can we push this technology? And I think it was very well captured by one of the questions that you posed is, we don't know. And that's what's exciting. That's what's edge research about. So moving on, I think to...
And I think I just want to highlight here on this picture that we see is also from one of the other speakers, from Josie Marie Griffiths, like the interaction in between the AI and the human.
Yes.
So there we go.
So the lab that... the Edge Learning Lab that Kim, our colleague, presented here, that's our launch pad, if you use space term. So what we do here in the consortium is, and the PhilLab and on the cybersecurity lab takes the Edge Learning Lab as its launching pad. And we have identified 3 initial research areas, application areas to go for, and that's mobility, space, and health, as you've seen here. We put cybersecurity not in a bubble by itself, but it really propagates the whole effort here. So we didn't want to represent that here as its own bubble, but as something that's part of the launch pad, something that goes across. So that's why it has a slightly different representation, but clearly one of the underlying features of what we want to do, to get it right from the beginning. And I think you've pointed to that too, Ebba, several times, that not only cybersecurity wise, but also legally wise. So we are very fortunate here to have a strong interest from the legal community to help us succeed and make sure that what we do actually will meet the requirements in the legal and the developing regulation. So this is the basic starting point for it. We expect new research areas to come up. And what you can see here is the overlap between the research area. And that kind of illustrates the idea of federating the learning that you do in space and in mobility and health. What solutions have you found in space that we could use on mobility? What did you find in mobility that can be used in health, and so forth? How did you solve the problems? What kind of cybersecurity issues did you run into? Are they relevant in other areas, and so forth? So we're also trying to illustrate how you can generate these synergies by running these different areas in the one place. And there's several opportunities, and I'm not going to go into all of the details of this. And there more will be coming out, but we are certainly looking at setting new research agendas, identifying new exciting problems. Some of them have been illustrated today. Driving the innovation breakthrough for industry in all these different areas, but also for the individuals, people who come here. This is a way for you who take that opportunity or get that opportunity to accelerate your career, to start a new research career if you're a young student or just graduating with your master's looking to do a PhD. Here is a great opportunity, working with some of the best companies, universities, and public organizations in the world. And also, if you're a student in the undergraduate or master's program, you certainly will have available opportunities here as well, doing, for example, thesis projects and so forth. So you can come and visit our website, explore the opportunities, and contact us, contact some of the other students who are here already and ask them, what can we do? And I'm very pleased to announce that we are together with Dr. Griffiths and the University in South Dakota, starting our first joint student program between AI Sweden and the cyber labs, the MAD labs over in South Dakota here this summer. So we are having a pilot program with 3 Swedish students and 3 students from the US working together on exploring cybersecurity questions related to the Edge Learning Lab.
That is really wonderful. And anything else you want to add on to the how?
Well, on the how, you can sort of just see yourself the different ways that you can engage. But one of the most exciting things we've seen here is, and that is also reasonably new, is that industry, companies, and public organizations, authorities have sent their employees here on their own payroll to actually come here and work for a month, 6 months, or up to a year even, to spend the time with us. And that's part of professional growth. They found that that's a more efficient way to learn about what's coming and help set the direction for their organizations by actually working here on site. We have some people doing that part-time, some people doing it full-time, and it's really a good opportunity, new opportunity to explore for those of you who personally want to try to talk to your employers, or to companies who want to send some people here to consider who would be a good person to appoint for that.
And you said we already have some people doing that, and we also see in the collaboration with ESA,
Yes.
we'll have a few researchers come over to have this interaction.
Yes, that's right. Starting this fall from ESA, I think. Yep. And for companies and organizations, authorities, and others to join, we are going to have different membership levels.
Specifically for the consortium.
Yes,
then,
that's
the
for the
research
consortium. Yeah, for the research consortium. And it depends on your level of engagement, and you can find more information about this on our website. But we have this lab sponsor level, which is the highest level of engagement. You have the creators, who are certainly engaged and have people here and want to have people here. And then you have the members, consortium members, who get access to the events, get access to the working materials that we are producing in the consortium prior to publication. And to find out more, contact Beatrice here at the email you can see there, and we can certainly send you more information about how to do it. And also visit our website on ai.se and search for the Edge Learning Consortium, and you will find more information. And if you are already a partner with AI Sweden, there are discounted rates to be in the consortium.
For sure. And Beatrice is one of our really great colleagues here at AI Sweden. And you can also find other people's contact information on AI Sweden's website.
Right.
And with that, we are supposed to finish up.
Yes.
So we would like to have Kim come up and join us on stage, because now we are doing the cutting of the ribbon, and it's going to be a cord ribbon.
Yes, I suppose that's the connection from here.
So
Well,
the moment of honor.
Yes.
Kim, please go ahead.
thank you.
3, 2, 1.